Hey guys, it's Miss Adams, and today we're looking at our third part of the notes today. So we're looking at our tennis ball notes. We're going to focus on capacity today. And the goal is to figure out how many tennis balls we can fit inside a classroom. So here is where we're going to start off with. We're going to consider the situation of determining the number of tennis balls needed to fill a classroom. So in class, I've given you guys time to talk to each other and estimate the number of tennis balls that can fit in a classroom. Now, realize we can't break these tennis balls in half. We can't squish the tennis balls, because if you've ever held a tennis ball, you'll realize although they bounce and everything, you can't really change the shape of them. So we can only fit them at the capacity where they're at. So we're leaving the tennis ball as is, not cutting it in half, not morphing it. Is going to stay the way it is. So at this point, you would compare your estimate with other people, and then you got to decide, is this too large, too small? I've had estimates of 50,000. I've had estimates of 100,000 tennis balls, but I've also had the estimate of like 500 tennis balls. In order to have a more accurate estimate or have a more accurate depiction of this, though, we can do this mathematically. So we're going to have some facts here. We're going to use the fact that the height of the classroom is 112 inches. So past couple notes with estimating crowds, we've just been looking at area. Today we're going to add in the third dimension, so we're going to be dealing with volume. So in order to have volume, we've also got to know about our height. We've got length, width, and now we've got height. We're using the fact that the height of the class is 112 inches and the diameter of a tennis ball is 2.63 inches. We're going to answer some questions below to compute how many tennis balls will fit in a classroom. So before we do that, I'm going to fill in some information that we learned in previous classes. So I know that the width of a classroom is generally 24 feet. And I know that the length of a classroom is usually around 28 feet. But notice that we were given height and our diameter in inches. So let's go ahead and convert these to inches. I know that 1 foot is equivalent to 12 inches. So I'm going to take that value of 24 and multiply it by 12 to get that the width of the classroom is 288 inches. I'm also going to know that the length of the classroom, I'm going to take that 28 and multiply it by 12 to get that the length of the classroom is equivalent to 336 inches. We were also given that the height of the classroom, so I'm going to go ahead and do this in a different color. The height of the classroom was given to us at 112 inches. All right, with this being given to us, we need to go ahead and estimate the volume of the classroom. Well, I know that volume equals length times width times height. I know my length is 336 inches. I'm going to multiply that by my width, which is 288 inches, and my height, which was given to us at 112 inches. So I have 336, multiplied by 288, multiplied by 112. That gives me a total volume of, let's see here, 10,838,016 inches cubed, because inch times inch times inch, that gives me 3 of them. So it's inches to the third power. So it's cubed inches. We're dealing with volume now. So we've got that third dimension. Now we got to estimate the value or the volume of one tennis ball. We were given that the diameter of a tennis ball is 2.63 inches. So if the diameter is 2.63 inches, I know the radius of my tennis ball is going to be half of that. So I'm going to take 2.63 and divide it by 2. So 2.63 divided by 2 gives me a radius of 1.315 inches. I now can plug this into our volume equation. So I have the volume of my tennis ball is going to equal 4/3 multiplied by pi multiplied by 1.315 cubed. And I'm going to plug it into my calculator just like that. So 4/3 multiplied by pi and then multiplied by 1.315 cubed. That's going to give me a volume per each tennis ball. Let's go ahead and round it to 2 decimal places. So I'm going to do 9.53. It gave me 9.525. I'm going to say that the volume is roughly 9.53 inches cubed. Well, now that we know this, we've got to figure out roughly how many tennis balls could fit in the classroom. Well, I know the diameter of each tennis ball. And diameter will also give me the same thing as the height, because that's it's the diameter, is how far across each tennis ball is, no matter which orientation you have of the tennis ball. So let's find the diameter of the tennis ball given the width, the length, and the height of the actual classroom. So if I am looking at my width, I know my width is 288 inches. And I'm going to take that to find how many tennis balls fit in there. I'm going to take my width and divide it by the diameter of the tennis balls. So I'm going to do my width, which is 288, and divide it by 2.63. And this is going to give me 109.5. But guys, I can't have that 0.5 of the tennis ball. I can only fit a true amount of tennis balls in there. So I'm going to say that my width can hold 109 tennis balls. I'm going to do the same thing with my length. So I'm doing that 336, dividing it by 2.63. That gave me 127.75. Again, I can't have part of a tennis ball. So I'm going to say that my length is 127 tennis balls. And lastly, I'm going to do my height. So I'm going to do 112 divided by that 2.63. And that gives me 42.58. Can't have a partial tennis ball. So I'm going to say that my height is 42 tennis balls. So now it's asking me how many tennis balls are going to fit in this classroom. So I'm going to take each of these numbers, the 109, 42, and the 127, and multiply them together to give me the volume of tennis balls that can actually fit in the classroom. So we got 127 multiplied by 109 multiplied by 42. And that's going to give me a total of 581,406 tennis balls that can fit in the classroom. Now I need to find the volume of all of these tennis balls. All right, well, I know that the volume of one tennis ball is 9.53 inches cubed, and I know that I can fit a total of 581,406 tennis balls within the classroom. All I have to do now is to multiply to get the total volume here. So I'm going to have that my volume of all the tennis balls was the volume of one tennis ball, which was 9.53 inches cubed, multiplied by the total amount of tennis balls, which was 581,406. Guys, this is going to give us a rather large number, and that's okay. So therefore, the volume of all the tennis balls in the classroom is approximately 5,540,799.18 inches cubed. Last question it's asking me is how much empty space is going to be in that classroom. Let's refer back. The original volume of the total classroom was 10,838,016 inches cubed. So I'm going to take that original number, and that's for my classroom. I got 10,838,016 inches cubed, and I'm going to subtract from it the volume of all of the tennis balls, which was 5,540,799.18 inches cubed. This is going to give me the empty space. So this is telling me what amount of empty space is left within the classroom. So I'm going to take 10,838,016 and subtract that 5,540,799.18. This is going to tell me that the empty space is going to occupy 5,297,000 216.82 inches cubed. So that's the empty space of the classroom. Last thing we need to do here, and I'm going to write this towards the bottom, is reflect on the volume of the classroom that's filled with the tennis balls. So what I'm going to do is I am going to take the volume of the classroom so I'm going to do a comparison here. I know that I originally had a volume of tennis balls at 5,540,799.18 inches cubed. And I know that the total volume of the classroom was 10,838,016 inches cubed. I want to know what that value is out of 100%. So I'm going to cross multiply. And I'm going to have that 5,540,799.18 multiplied by 100. I'm going to divide that by my 10,838,016. And that's going to tell me that I have a percentage of 51.12%. So my tennis balls only take up 51.12% of the classroom. All right? So I want you guys to do some reflection at the end of this here. So this was for question 6. My reflection needs to say, how close were your initial estimates to the mathematical estimate? Guys, I said it could be 100,000. I was a little bit closer when I said about 500,000 tennis balls could fit in the classroom. I was really low when I said 500 tennis balls could fit in the classroom, okay? Realize we were making the assumptions that no desks were in the classroom. So what would happen if we did have desks? We would have to subtract that from the total volume of the classroom. There's a lot that we can do here. I hope this kind of gives you an idea of how we can estimate capacities within a space though. Have a great day, guys.